perfect. Then, okay, we are going to talk about machine learning operation in Google Cloud Platform. It's something that is starting to move in the last 2 years, and I think that it's going to be something really, really common in the next 10 years or maybe more. And first, I'm going to introduce me a bit really quick because I've been doing introduction before. This is me. I'm PhD in computer science. I'm big data and artificial intelligence architect, and I have been research and teacher in different universities around the world. And I'm GG machine learning and Google Cloud Platform, and this is my social network. If someone wants to ask me anything about machine learning, Google Cloud Platform, or something related with artificial intelligence, my chats are always open, and you can contact me in any of them if you are interested and have any question or something about anything related with these topics. And now the important thing, what is the point of this talk is to talk about machine learning operation. And during this talk, the objective is to try to understand why machine learning operations are useful, what is a machine learning operation process, how it's working, and how we can create these kind of systems or process in Google Cloud Platform. Then we are going to start from the beginning. Why do we need machine learning operation? This is the most important question. Why it's important to start to create this kind of system or this kind of process. If you can see, this is the traditional way to work with algorithms. This is the way in which humans create any algorithm. We have an algorithm that is composed by a group of rules. This is the code that programmers put in the algorithm, and we have some data that is the input that we use to generate an answer. Okay, this is the traditional method to create an algorithm that we are going to call traditional. But now, with machine learning, we create a new way to create algorithm, something a bit more complex. Because now, with an algorithm that have an answer, a group of answer, and a group of data as input, we can create a group of rules. The things that before we were creating by humans. Now we have to do this. But now this algorithm, it's an algorithm that is creating another algorithm, because this model, that is the output of a machine learning system or a machine learning algorithm, it's another algorithm, something like can reasoning about a specific topic. For example, can identify people in a picture, or for example, we can predict the price of a car, of a house, which is really, really interesting because we are creating code from code. And okay, we are going to do some in the important part. It's the part related with machine learning, in which we have this. We have an input, that is the answers, depending on the machine learning algorithm that we are going to use. And we have data, which is the information that we are going to use to learning. And the output, of course, is a group of rules, which is the model. We are going to pack in a model to be used in the future. But the question is, what is inside of the blue box? There are common knowledge about there is no more than an algorithm that take it all of this information and generate this information to create something that looks like an artificial intelligence, like human reasoning, something like that. But this is not true, because if we open the box, there are many things. And the part of the machine learning algorithm is the smallest one. This is the black box that we have here, which is really small. But this is not going to work if we don't have all of this. Mostly of the time, many of these things are not including or are included into the machine learning code. But this is not a correct, proper way to do that, because all of this process or operation or anything, okay, have to be independent of the algorithm, because if not, the algorithm depends on all of them. And as we can see, we have different kind of process. We have process related with configuration of the different modules. We have data collection, feature extraction, or data verification to understand if the information that we are going to provide to the algorithm, again, the small black box, it's okay. And even more, we have everything related with the matching resources. We have analysis tool to analyze what is happening in the algorithm before and after. And we have serving infrastructure, all the things that we have to put in the cloud or in the on-premise infrastructure to serving our model, to let the clients or the user use that machine learning model that we are going to create. And of course, we have monitoring to monitor all the process. And if you want to know more about all of these that we can call now the machine learning cycle, okay, you can read this paper from the Google team in which they explain which is the depth, the technical depth that we have in machine learning system, in which we think that there is only a small black box or a big black box that have a simple or a complex algorithm, but there is not anymore. And for this reason, everything or in machine learning operation, it's really important. We are going to try to make an ordination of the different boxes that we have in the previous one. If we try to organize the order in which these different boxes are going to be executed, we have something like that. We have the answer and the data, that is processes for different kind of data process. We have data ingestion, they have data collection, feature extraction. All of this information transfer the data to pass to the machine learning code in which we are going to do the training, the real machine learning part. And after that, we have to do many things related with the packing, to packing the solution of this, or maybe to packing the code. And we have to process with different tools how to execute this code. Okay, this is gonna generate that model that we need. And we have to register the model in any tool, maybe in a repository or maybe in another place. And we have to validate if the model is okay or not. We have to verify the model too. And we have to analyze how this model has been created. And finally, we have to serve in the model. And we have to understand how many users are going to use that model in order to deploy the specific or the basic infrastructure to making the serving process working really good. And of course, as I said before, we have to monitor everything that happened here in this process. Then if we organize the different tasks in these ways, we have to change another big things. Now, the output of the machine learning cycle is not an algorithm, it's not a group of rules, it's not a model, because the model is a subproduct between the part of training and the model registration or model validation process. And now the output of this machine learning system is the answer that we get with the data that is using the serving process that is here working. Then, as we see, we have many operations that we have to define to create a real machine learning cycle in which we are going to create a model and serving. And the way to do all of this is to starting to use machine learning operation, because all of these are part of those operations. But the important thing is that we can try to simplify a bit more and transform the operation in these 5 big groups: data preparation, training, model packaging, model validation, model deployment, and finally monitoring. And now we have the basic operation that we can find in a machine learning process. And this is the thing in which we have to focus to understand why it's important to define all of this and not only the training process. Because at the end, the objective of a machine learning process is to try to create a continuous training system which is based in machine learning. And how we are going to do that? Or which is the objective of this? Why we want to create a continuous training? Because at the end, the thing that we try to find with machine learning operation is to industrialize the process of generation a product, which in this case is a model. We have to define a system that allows us to think in new ways to create models, have an infrastructure to training and deployment this model, and finally, industrialize the process of improve that model with different versions in a really, really simple environment, which can be monitored to understand what is happening with our models. And this is the reason for which we need to use machine learning operation to simplify and industrialize the process of model generation. Okay, I think that everything is clear from here. We are going to see what are exactly the machine learning operation, because maybe it can be operation maybe can be those boxes that we saw, but not exactly. I suppose that everybody knows this. This is the typical DevOps environment, DevOps representation, okay? When we had to define the DevOps operation, which is a set of good practice that allow us to combine the software development and the IT operation. Because using these, combining these good practice, we can create better software and we can industrialize the software production, making the change really easy and creating a really, really comfortable environment to create new issues or new functionalities for our software. But this representation or this traditional develop operation, it's based in two important concepts. The first one is the continuous integration, which is that part that allows the developers of the team to integrate code in that repositories that are super famous and super useful. And usually this code, this integration must be verified by an automatic builder and automatic tester in order to analyze if that new integration, that update, it's working well. And the other concept is the continuous delivery, which allow us to make the software ready to be released at any time, creating short cycles of software development. These are the two major concepts of DevOps and are really, really useful for DevOps, but are not enough for machine learning because machine learning system differs a lot from the other software system. Because in this case, we not only have to create an algorithm that create another algorithm, a model, we have to analyze and validate many information. Now we are working with data. For this reason, we need to validate this data. Now we are working with models. We have to validate the models, if they are working well, or if they are created in a good way. We have to analyze the quality of the model. We have to identify or deploy the model to make it ready for the user. And we have to monitoring all the data that we are using for training and for model creation, and we have to analyze how the model is behaving. What is the performance of the model when we do that? And with this group of operation, it's impossible to do that. We can do that. Then for that reason, we including a new set of good practice related with machine learning generation, in which we are going to focus in the model and in the data in order to introduce new behaviors and new good practice for this. Then now, the two major concepts that we saw in the DevOps are not enough. And we have to modify a bit how it's working and introducing a new one. In this case, we have to introduce the concept of continuous training, which is something that only appears in machine learning system, because we have to create systems that update, improve the model during the machine learning cycle. And these have to be automatically. It's necessary to retrain the model and serve it in an automated way to allow the user to have the best model that usually can be degenerate really, really quick. But not only this, because the concept of continuous integration can change, because now we not only have to analyze the code and testing, we need to test the data and see if the data is in the correct way, correct representation, and we have to test the model. If the model that we are generating, it's working well, and is the thing that we expected. And finally, the concept of continuous delivery now is changed. It's a bit more complex because in the DevOps systems, we only have to deliver a group of software. And in this case, we have to deliver two. The one that is creating the machine learning model, that usually is called the machine learning pipelines, and the one that is deploying the model for inference to let the users and the clients to use that model. And this is the new things that machine learning operation bring us, making a bit more difficult the industrialization process and give us more things to control and create better software, in this case, based on machine learning. Okay, now we understand how it's working, what is exactly machine learning. But now we have to see how can we create a machine learning process, because it's something that we have to understand before to start to deploying in the cloud or in another kind of environment. Usually, when we are going to create a machine learning operation system, we have to analyze which is the level of automation that we need. Because depending of which level we are going to choose, more complex will be our system. Unfortunately, mostly of industry is here in the level -1, in which we do our machine learning models in a computer, in our personal computer or work computer, in which we create the model, we define the model, we save the model, and if we are lucky, we put in any repository to use that model. But this is not the proper and the correct way to do. Then now we are going to try to explain which is the difference between level 0, level 1, and level 2. Because this is the models in which we can start to see something related with machine learning operation. The first one is the automation level 0. This is the level that we call manual training and serving. Okay, but this is not manual training and serving like if you do in your computer. In this case, we are defining a process in which we define or split the different actions that we need to train a model. Okay, we have all the part related with data extraction, model training, model evaluation, and validation. And finally, we have a model that if we are available, we can put that model in a model registry. If not, we can keep it where we want, maybe in a repository. And finally, we have the part of machine learning operation, in which we are going to deploy the model for serving, for example, in a web application or in an API REST. And all of this part, the machine learning part, and this part, the operation part, are commonly done manually. Usually they are driven, if we are lucky, in a notebook, and we execute that notebook and generate a solution, in this case a model, and put manually in the deployment environment. This is okay, it's good. It's mostly the thing that is done in the industry and in research, but this is not enough because there is not any of the properties that we described before. There is not continuous integration because usually notebooks are executed manually to generate the models. Okay, can be automatized, but it's not the common thing. There is not continuous delivery because there is not model updates or code updates. Okay, maybe some one of you are thinking this is not true because we can update the model. Okay, we can update that manually. And the objective is to automatize this process. And there is not continuous training because the system doesn't train automatically a new model. A manual user, a developer, have to execute the notebook again. Then here, there is not any automation level. But it's okay. It's in the good direction because we described the different areas, we separated the information and the process, and we are close to this. If we want to introduce some automation, we have to move to the level 1. And the difference between level 0 and level 1, it's really, really big. This is the difference. As we can see, the system is a bit more complex. Now we have all the process that we see before. And all of this process, okay, from data collection to serving, okay, serving the model, it's inside of a pipeline, okay? This is the basic element that we introduce in machine learning operation, the concept of pipeline, which allow us to define all the process that we are going to execute. And this pipeline is updated into the machine learning operation system manually. But when the pipeline is being updated, the automation starts because the execution of the pipeline, the execution of the code that train the model, it's going to be executed in an automated way. And when the model is published in the model repository or in the model registry, it's going to be serving automatically. Then all this part, the training and the deployment or serving, it's going to be automatic, but not the software production process. But okay, in this case, it's better than nothing. It's better than the previous one. We automatize part of the process. This is the thing that we start to see in the industry. There are some companies that are starting to do this, and it's working really, really well. But this is not enough, because now, okay, we get the continuous training, because this process, once the pipeline is updated, can retrain the model automatically. Then we have this. Good. We have partial continuous deployment, continuous delivery, because the model, it's going to be delivered automatically. Not the pipeline, but the model is going to be. But there is not continuous integration, because the pipelines are executed automatically, but the updates of the code have to be done for the machine learning engineers or the data scientists. But okay, this is really good. We have some automation. And now, if we want to do it better, we can go to the top level, automation level 2, where we have full automation process with continuous integration, continuous delivery, and continuous training. In this case, everything is fully automated, because we have the same schema, but we have the part in which we create the pipelines, and when the pipelines is modified, starting a new cycle. This is the objective. This is the thing that we have to follow in the next year to create a real machine learning operation process, to fully automatize the generation and deployment or serving machine learning model. Okay, and now the interesting part, how we can do that in machine learning, how we can do that in Google Cloud Platform, how we can create a machine learning operation in Google Cloud Platform. Okay, remember this picture that we have? We have the different things that we are going to put in our pipeline. All of these are the different phases of the pipeline. Okay, then we can do this. With this, we can create in Google Cloud Platform a real machine learning operation process of level 2, because we have all the code, which is defining with notebook, with scripts, with anything that we want. We have all the part related with building the containers that we are going to use in for any of these part. Any of these operation can be a container that execute a specific action. We have a container registry in which we are going to storage all our containers, and we have a Google Cloud Storage in which we are going to store the pipelines that are composed by the containers. And once we have all of these, we can execute the pipelines and generate our models. And which is the technology that we are going to use? Of course, Kubernetes, for execute all the pipelines and all the process that we have to execute for training and for serving. We are going to introduce the concept of Kubeflow, which is a system that allows us to orchestrate the pipelines for machine learning. We can use even Google AI Hub for model registry, because they offer a way to register the models, or for training if we want. We are going to use Google Cloud Storage to store data, models, and the code of the pipelines. Data flow if we want to process data, or even for model validation, because there are different ways to do this. And of course, container registry, because we are going to store the pipelines components, all the process that we have there. Okay, now we know which is the technology that we are going to use, but we have to try to understand or explain what is Kubeflow. Kubeflow, it's something, it's like an application, like a middleware over the Kubernetes that introduce different applications for machine learning production. For example, we have something like Argo, that is a system to orchestrate the pipelines for machine learning process. We have TensorFlow, of course, because this is a product done in collaboration with Google. We have TensorFlow board because we want to see what happened with our machine learning with our machine learning process. And we have, for example, Seldon, which is a serving technology that work really, really well with Kubeflow. Then Kubeflow, it's like a mix between machine learning and Kubernetes, because all the process that we are going to execute here are going to execute it in Kubernetes in an easy way for us. And the good point is that Kubeflow and Kubernetes can be executed in mostly of the cloud system, not only in Google, but we can use in all of them. But now we are going to focus in Google. Okay, Now it's clear what is the process that we are going to try to do and what is the technology that we are going to use. And now how we can do that. Okay, there are two ways to deploy your Kubeflow system in a Google Cloud Platform. There was a super really good way to using this system, which is a simple form in which you can connect with your Google Cloud Platform and the system deploy your Kubeflow environment. And the other way, it's the traditional way, installing everything with this manual that we have here in the web page of Kubeflow. But today, or not today, some weeks ago, this page stopped to work, and Google didn't offer a web deployment anymore. There are other ways, but this is not possible now. Then the only option that we can do is to follow these rules, this set of instructions. It's really easy. You only need 1 hour, and it's really well explained. In my opinion, it's one of the best tutorials that I follow to install something. And in this case, you are doing many things. You are going to configure your Google Cloud Platform. You are going to configure your Kubernetes cluster, because you have to do before. You are going to install many tools to control Kubernetes, like Prometheus, Istio, and other tools. And finally, you are going to install Kubeflow, and you can use it. In 1 hour, more or less, you can try to do it. It's really easy. But there is one thing. It's not possible to install or use it well if you are using the free tier of Google Cloud Platform. This means that you have to put your credit card and be ready to spend some dollars or euros to work with this technology. But okay, if you are K-Tunes and you are worried about your system and your Kubernetes cluster, okay, that is not really expensive. Then you can try, and it's really good. Okay, once that we are executing or generating that Kubeflow cluster, that Kubeflow technology, we are going to create something like this. This is the web application that we are going to use to enter to Kubeflow. That is composed by a name that we have to define in the installation and the project in which we are going to use it. This is the one that I'm using right now. Okay, this is my project, MLOps Kubeflow, and this is the name of my Kubeflow technology. Okay, Kubeflow system that I'm installing. And then if I enter in this application, I have something like this. This is like a web application panel in which there is all the information about Kubeflow. Okay, the good point is that we have to create pipelines here. We have a notebook server here. We have an artifact storage system, and we have many documentation. It's really simple to create something. But we are going to focus in the pipelines because it's the important thing. A pipeline is like a group of processes that are executing to develop that machine learning model. Okay, this is really useful. And you can see here how to use one of the most common pipelines that you can find in the Kubeflow technology documentation. Sorry. And once that you are downloaded this, you can see something like that. Sorry if you can read it. Okay. This is all the information that you use to configure the pipelines. Okay. I'm going to put the slide, then you can see in details all of this. Okay. There is information about the configuration. There is information about the different process. There is information about the Google Cloud Platform and the configuration of the project and anything that we have to put in the pipeline. Okay. As you can see, this is Python code. Everything is written in Python. And if, for example, you have using Google Composer or Apache iFlow before, it's exactly the same. And then this is the pipeline. Okay, this is the different process that we are going to define. As you can see, we are only putting information about which is the process, which is the name, and in some cases, which is the input and the output. All of these are the different operations that we are going to execute. And if we say, once we have all of these, the only thing that we have to do is to compile our pipeline, okay, using Python 3.6 or higher, and generate and tar GC artifacts in which there are the information about of pipeline. To do this, the only thing that we have to do is creating a main in this code and compiling using the Kubeflow compiler system to create a tar GC artifact. And now we have the pipeline. But okay, mostly of you are thinking about what exactly this that we have here. Okay, we are going to try to explain in a bit. Now we have this artifact. We can put the artifact in our Kubeflow system. In this case, my artifact was stored in Google Cloud Storage. Then I'm trying to do it manually, the thing that I want to automatize. Then when I create this in the pipeline, I'm putting in the cloud storage bucket, and then I can use it in Kubeflow. Now, when I do this, I have my pipeline, and this is the pipeline that I wrote it. As you can see, I have 5 different processes. The first one is related with data collection. The second one is related with training. This is related with collecting some metadata from the data collection. And finally, we have the serving action or operation and the metadata from the training process. If you remember in 2 slides before, we have exactly 5 operation here. The first one is related with this, the second one is here, third one, fourth one, and finally 5th one. All of these are related using a specific code that is available in Kubeflow. But this is a special one. And after some slides, we'll see what is happening. Okay, once we have our pipeline, we can execute it manually, and we can do all of this, defining the pipeline, naming the experiment, and using the configuration. In this case, I use it the default one. If you can see, this is a process to level 1 automation, because I created the pipeline, and now the system is gonna work for me. And when it's starting to work, it's gonna do something like this. It's gonna execute the pipeline. Now it's stopping, okay, it's waiting, it's training here. And the process is gonna finish to create it a serving model that is gonna be deployment in Kubeflow. This is the way to create a machine learning operation in a really simple way using Kubeflow. But okay, remember that we talking about this pipeline that is a bit different of this. That is because you can create your own components for pipelines using Google Container Registry. This means that you can create a container that you can store in Google Container Registry, and you can call it from the pipeline. And this is the way in which you can remove all of this and put your own process to create your own pipeline with your own coding. And what is the way to do that? It's really simple. We only need 3 elements. The component source code, this is the Python, okay? The deployment file, which is the way in which we created the container by using Docker. And finally, a file to define the pipeline, which is the thing that we have here. All of these are related with the component definition, and this is related with the Docker directly. And how we can create all of these files? Okay, the first one is the easy one. This is a Python code. You have to put here the things that you want and prepare your training model, your data collection model, anything that you need. After this, you have the deployment file. Okay, this is the way to create your container and put it in the Google Container Registry. Then in this case, we create an image. Of course, we have to do in our zone. In this case, I'm going to put in the Europe Container Registry, because if I put in another place, maybe I can access to it. And I'm going to execute the Docker build and the Docker push to put my system. Okay, if I put here my organization and the name of my image, the push process put it in my Google Container Registry that is related with my organization or my user. And finally, we expect to see if the container is properly updated into the Google Container Registry. Okay, this is enough, but we can do it better. We can create these that allow us to create a final component in Kubeflow, in which we introduce the information about the input, the output, the description, and everything. This means that this component can be used in Kubeflow in any way and for any pipeline. Then we are introducing a new concept to productize, to industrialize the creation of these components that allow us to create the pipelines. And this is the way to create a machine learning process of level 1 using Kubeflow, but can be done better, because you can automatize everything that you want with the different tools that Google offer you to try to do all of this in a fully automated way. And to finish, because I don't have more time, the conclusion of this talk are 3. The first one is machine learning operation. It's something that is going to happen during the next year a lot, because it's possible to automatize the machine learning training and serving process by means of pipelines that can be modified really easy. Besides, Kubeflow allow us to use containers to define our operation, which allow us to reuse in other pipelines and create really complex system for machine learning operations. And finally, one thing that is really good is that Kubeflow can be executed not only in cloud, can be executed on-premise. You can install Kubeflow and all things related with it in any system that you want, and not only in Google Cloud Platform. Even if you want, you can share between Google Cloud Platform, Azure, or other kind of cloud, the different components in order to create more complex system. And this is all. I'm really happy to be here to speak in DevFest Italy. Then thank you. And this is my Twitter. If you have any question, I will be really happy to answer now or maybe in the different social network. And one last thing, this is a really simple form. I really appreciate if you fill it in order to know which is the feedback that you are giving to this talk to improve it for future talks related with this. And thank you so much for everything.
Thank you, Moiśes. And we have a question ready. I'm going to ask you if you can stop your screen sharing so I can share mine, and we will go. Thank you. I'm going to share my screen. Okay. Says how we can rapidly verify if unexpected behavior is caused by data or by our model in continuous training.
Okay, that's depend of which is the thing that you're introducing in the components. If you are introducing something that is related with the data, you can check it. Okay, and the system, it is monitoring, can see. And if you are doing in the model, you are defining some rules that analyze your model, you can check what is that. It's depending on how complex you can do the code, and the system is going to execute it for you, and then stop it if something happened that is not the thing that you are expecting.
Okay. Next one. What are the main advantages of using Kubeflow over using Airflow and orchestrating GCP services for the heavyweight computation?
Okay, Kubeflow and Airflow are different things, are quite similar, but not exactly the same, because Kubeflow is introducing all the machine learning technologies that in the case of Airflow are not available. And then if you are using Kubeflow, that is not only for orchestration, you can execute or you can use in all the other components. For example, for orchestration, it's using Argo, and you can use, for example, Seldon for serving, and you have all the things related with TensorFlow inside. In the case of Airflow, you can use Airflow to orchestrate process, but you have to find a way to make an interaction between them. And this is not the only thing that do. Then Kubeflow has more properties focused in the machine learning process. And you can do, if you want, I created before, in the past, machine learning operation process in like an automated way using only Airflow. But it's a bit more complex, and I don't have all the resources that, in this case, Kubeflow allow me to use. Then, okay. The main advantage is that include all things related with machine learning.
Okay, great. And I think that's all with the questions. Moiśes, I thank you a lot. It was very interesting, and it's been a pleasure having you in this DevFest. So I'll say thanks to you, and we have a short break now, so let's see again in 15 minutes for the next talk. Thank you, Moises.
Thank you so much, Gregorio. It was a pleasure to be here.